Welcome back to the Explainer. I'm so glad you could join us today. Now, right off the bat, I want to let you know this Explainer is brought to you by Forge College. So grab your hard hats because we're diving straight back into our Ethereum fundamentals track. Specifically, we're jumping into the Calculating Gas Usage module to tackle exactly what it says on the cover. Step-by-step transaction fee calculations. It's an absolutely crucial skill for any Web3 developer or informed user to have in their toolkit. Now, if you're experiencing a little bit of whiplash right now, totally fair. In our last Explainer, we were floating high up in the clouds, taking a breezy, big-picture look at the Solana cloud overview and architecture. Today, we're crashing right back down to earth. We're trading those clouds for a dark green technical pen and getting deep into the weeds of Ethereum's strict deterministic math. But hey, don't panic. I promise we're going to take this one perfectly drawn step at a time, and by the end, you'll be running these numbers in your sleep. Okay, let's dive into this. Our agenda for today is straightforward. 1. The gas fee formula. 2. Units, gwei, and wei. 3. Simple ETH transfers. 4. Smart contract interactions. 5. AI vibe coding script. And 6. Recap and next steps. We're going to start with the theory before we throw any real numbers at you. Section 1. The gas fee formula. Like a restaurant receipt. Let's think of an Ethereum transaction fee exactly like paying your bill after a nice meal out. Your gas used is the actual food you ate. It's the computational work you consumed on the network. The base fee is kind of like a mandatory state tax that just gets burned and disappears forever. And the priority fee is the tip you slide directly across the table to the validator for their prompt service. Put it all together and you get your final bill. And that brings us to the effective gas price, which is literally the heart of our deterministic formula here. Under EIP 1559, it's just the sum of the per block base fee and your chosen priority fee, your tip. So the total transaction fee is always going to equal the gas used multiplied by this effective gas price. That is the golden equation we'll be leaning on for everything moving forward. And this brilliantly illustrates how those base and priority fees actually stack up in everyday scenarios. Compare a typical simple Ethereum transfer to an ERC20 token transfer. The computation, the gas used, jumps from exactly 21,000 up to somewhere between 50,000 and 100,000. And notice, even with the exact same network base fee of 100 gwei, you might bump your priority fee slightly for a more complex contract interaction, just to ensure it gets picked up. Multiply it all out, and you see exactly how the mechanics scale. Section 2. Units, gwei, and wei. Respect the zeros. Before we can actually do that multiplication ourselves, we really need to master the language of Ethereum math. And I gotta warn you, right here now, precision is absolutely everything in this space. If we want to avoid an off-by-one calculation error that could cost you or your users real money, we have to respect the zeros. 1 gwei is 10 to the power of 9 wei. 1 full ETH is 10 to the power of 18 wei. The absolute secret to success here is to preserve integer semantics for wei math whenever it is humanly possible. Floating point rounding surprises are basically the arch nemesis of accurate blockchain math. Keep it in integers, and you keep it safe. Section 3, Simple ETH Transfers. Manual calculation number 1. All right, theory and vocabulary complete. It's time for our very first manual calculation example. We're going to build your confidence by scaling the complexity slowly using the rule of 3. We'll start simple, get slightly harder, and finish with a heavy scenario. Here are the raw inputs for our first test case. The gas used for a standard transfer is a hard-coded 21,000. Let's say the network base fee is currently 120 gwei, and we're tossing in a priority fee of 2 gwei. So the crucial point is, when we calculate the total, we are multiplying by the actual gas used, not the gas limit cap you might type into your wallet. The gas limit is just a safety net. The gas used is your actual consumed meal. Let's move to and see how this builds step by step, from tiny gwei all the way up to Ether. First, we add the base and priority fees to find our effective gas price. 120 plus 2 gives us 122 gwei. Second, we take that 122 and multiply it by our 21,000 gas used. That equals 2,562,000 gwei. Finally, to make it readable for a human, we convert that up to Ether by dividing it by 10 to the 9th power. And there is our beautiful result, 0.002562 ETH. Now, this isn't just a random estimate. This is the exact deterministic cost of that simple transaction. If you wanted to report this to a user in their local fiat currency on your app's interface, you simply take this exact ETH amount and multiply it by the current market price of Ethereum. Pretty straightforward, right? Section 4. Smart contract interactions. Manual calculation number 2. Now let's pivot to slightly heavier operations. I want to remind you that while the inputs are going to get visibly larger here, the core formula we just practiced stays exactly the same. The underlying math doesn't change one bit, just the scale of the execution. So, for an ERC20 token transfer, our gas used jumps to 65,000. The base fee is a bit lower today at 90 gwei, and our priority fee is 4 gwei. It's incredibly important to point out that ERC20 transfers vary wildly depending on their specific smart contract implementation, so you should always use the gas used from a network estimate rather than just guessing. Let's run this arithmetic real quick. Step 1. Find the effective gas price. 90 plus 4 is 94 gwei. Step 2. Multiply that by the gas used. 94 times 65,000 equals 6,110,000 gwei. And step 3, we convert that gwei straight up to ETH to see what it costs. Notice how the gas used simply scales the overall cost perfectly linearly, which lands us right at 0.00611 ETH. That's your final cost for this specific contract interaction. And hey, make absolutely sure you're carefully tracking those decimal placements. A single zero out of place here is the difference between a smooth user experience and a highly frustrating failed transaction. Now for our third and final, heaviest manual test case, a complex swap, like trading tokens on a decentralized exchange. The computational cost, our gas used, explodes to 180,000. And check this out, the base fee has spiked massively to 250 gwei due to high network congestion. We've also bumped our priority fee to 10 gwei just to ensure we don't get stuck pending. Let's guide this through together one last time. The effective gas price is 250 plus 10, giving us 260 gwei. The total fee in gwei is 260 multiplied by that massive 180,000 gas requirement. That yields a staggering 46,800,000 gwei. Now let's divide to convert that up to ETH and see the damage. We hit 0.0468 ETH. Wow. That is a significantly steep final cost. And honestly, this validates exactly why calculating costs ahead of time is such a critical, fundamental skill for developers. Look how incredibly sensitive the total cost becomes when that base fee surges. If you don't calculate this in advance, your users are going to be in for a very nasty surprise. Section 5, AI Vibe Coding Script, Automating the Math. Okay, take a breath. You have officially survived the manual math. You can definitely frame this next section in your mind as your reward. Now that you intimately understand the exact mechanics, let's learn how to make artificial intelligence do all this heavy lifting for us by generating an AI Vibe coding script. If you're using an AI assistant to write your code, you've got to be extremely precise with your prompt. For example, generate a Python script named tx_cost.py that accepts gas_used, base fee_gwei, priority fee_gwei, computes total fee_wei using integer math. I want to really emphasize that last instruction. By explicitly telling the AI to use integer math, we force it to play by Ethereum's golden rule, ensuring it doesn't hallucinate floating point errors that could completely tank our fee calculator. But once the AI spits out the code, you can't just trust it blindly. You need a script validation checklist. And guess what? Those 3 manual examples we just suffered through together, they are now your canonical test cases. You'll test the AI script with our simple transfer, the ERC20 transfer, and the complex swap. Ensure the ETH matches to 6 decimal places, verify the fiat conversion consistency, and always check those intermediate gwei values to make sure the core logic is actually sound. Section 6, Recap and Next Steps, Theory to Code. Now, what's really interesting about this slide is how we've transitioned from abstract theory to reproducible deterministic code. We started with the basic gas formula, we mastered the language of gwei and wei, we ground through the manual calculations to understand the scale, and we ended up with a rock-solid blueprint for an automated AI calculator that you can trust. So I want to leave you with this final provocative thought. How sensitive is your transaction cost to base fee swings? The next time you're architecting a decentralized app or writing a smart contract, keep that exact question at the front of your mind. Optimize for gas and protect your users. I want to say a massive thank you to Forge College for bringing us this explainer today. To continue your Web3 journey, run these calculators yourself, and master more topics just like this, I highly recommend you visit forge.college. Thank you so much for joining me. Stay curious and keep building.